Okay, so this is a video from C2 for a few examples to help you with solving trigonometric equations. So let's start with a question. Okay, so let's solve 2 cos theta equals negative root 2, and we want to solve that in the range from for theta from 0 to 360. Okay, so the first thing we want to do is rearrange that equation, so we get cos theta equals negative root 2 over 2. Shrink that down. Okay, so remember those steps then. First thing we're going to do is we're going to do inverse cos of the positive version of that number, because we just want to get that principal value, so that gap that's in the graph. Okay, and that's going to be equal to, on your calculator, 45 degrees. Just stick up with that. Okay, then we want to just check that value there, whether it was positive or negative, because that is telling us where that kind of angle ends up projecting onto the y-axis. So we've got, well, cos is negative, so we'll be looking for angles in the negative quadrant. Alright, so cos is negative. So write that down, so that stops you, slows you down with your working, and just makes you think of that step. So now, sketch out your axes for all schools torture children. So we've got all schools torture children. We want 45 degrees in the quadrants where cos is negative. So we've got the all positive there. Only sine is positive there, so we'll have an angle in there because cos is going to be negative there. In that one, only tan is positive, and in that one, only cos is positive. So the other one is going to go in there. Okay, so we've got, just make my pen smaller, we've got a 45 degree angle there, and a 45 degree angle there. So now we look at our range. Okay, so we remember 0 is starting there. Okay, and then we've got 0, 90, 180, 270, back to 360. So we're going to spin around in that direction. So from there, around in one turn, reading off the size of that angle. Okay, so that angle there. And then we're going to spin around again to that angle. So that bigger obtuse angle there. Okay, or reflex angle, sorry, not obtuse angle. So the first one, that angle there, is just going to be 180, take away 45. So one of our answers is going to be 130. Oh, that's an awful colour. Let's get rid of that. Let's just get a better one. So one answer is going to be theta will be 135 degrees. And then if we spin around again, we'd have 180, add 45, so the other answer is going to be 225 degrees. Have a quick check that those two answers lie in that range, and they do, so therefore that's correct. Alright? Right, so let's start another equation then. We'll do, this time, sine of theta minus 1 inside a bracket, multiplied by 5 cos theta plus 3 equals 0. Okay, and we're going to solve that in the same range as the previous one. So that's going to be between 0 and 360 degrees. Okay, sorry, 360 degrees. So I'll just shrink that, stick it up there. Okay, so now this is like a quadratic equation. So we've got a number there, multiplied by another number. So two numbers multiplied by each other and given an answer of 0. So that means either that bracket would be 0 or that bracket's going to be 0, just like you would with a quadratic equation. So we can set up two equations now. Either sine of theta minus 1 would be equal to 0, which would give us sine of theta is equal to 1. Okay, or we could get 5 cos theta plus 3 is equal to 0, which if we take the 3 to the other side, then divide by the 5, that's going to give us cos of theta equals negative 3 over 5. Okay, so all we're going to do is then just solve those two equations separately. Alright, you can do the easy but confusing one first. So I'm going to solve this one first. Okay, so if on your calculator we start off inverse sine of 1, that's going to be equal to 90 degrees. Okay, now the easiest way I think to think of this one, rather than using old school taught to children, because if you use that ASTC, that 90 degree angle is going to end up being put onto the y-axis, which can get a bit confusing. So I think with this kind of question, it's easier just to go back, just remember the shape of the sine graph, which goes like that. So that's 90, 180, 270, 360. So in the region 0 to 360, inverse sine of 1 just gives us that one answer anyway. Okay, so from that graph, we can know that there's an answer there that is theta is equal to 90 degrees. Okay, and then we're done with that. So now if we go over and look at this one, okay, just follow the same pattern as we did before. So first things first, inverse cos of the positive version of that number. So it's going to be 3/5, which is equal to 53.13. Okay. Sorry, just group these together. And shrink that, stick it over there. So we can now look at the number that we had when we had cos, or in terms of sine or tan, theta equals something. So we check what that number is. That number is a negative number. So remember that means we're going to be plotting that 53.13 where cos is negative. So we got all schools taught children. So that is going to go in the S quadrant. So that's where sine is positive. In the T quadrant. So we've got, let me just make my pen a bit smaller. We've got 53.13 there and 53.13 there. And again then we spin round to get our answers in that region up here. So we're going to get that angle will be 180 take away 53.13. So that's going to be, let me just work out my calculator, that's going to be 126.87. Okay, so we've got 126.87. The other one, that reflex angle there is going to be 180 plus 53.13. So that's going to be 231.13. So to conclude all of that then, our answers are going to be, we'd have, and just to put them in order, so we'd have, our angles are 90 degrees, coming from that solution there, 126, let's just round it now, 0.9 degrees to one decimal place, and 231.1 degrees also to one decimal place. So there's three answers there. Okay, so if we were to draw the complicated graph of that and looked at where it was crossing the x-axis, we'd be crossing at those points there. So if you want to check that out on Desmos, you'd probably get a strange looking graph from that. Right, okay, so that, hopefully those examples will just help you work through that exercise 10b. Okay, off you go. Oh, I'll do a further example on radians in another video. Okay.